all going to take a quick moment just to appreciate my drawings of the neutrophil and the heart and the lungs and the thermometer which I spilled my tea on but couldn't be bothered to redraw it. Thank you. Thank you. Beautiful, isn't it? Guess what we're covering today? The blood has many functions in our body. It has its own army to fight off pathogens. It distributes heat, it carries hormones around, it carries oxygen to our cells, and then it carries away waste products such as carbon dioxide and urea. So the blood is composed of hormones, steroid and peptide. It also contains nutrients such as amino acids, ions, and one of the most important ones, which is glucose. It also is carried all by the plasma, and another large component of the blood are your leukocytes or your white blood cells. They're like your own army. Then you've got your platelets to help with blood clotting. And finally, what we're going to be focusing on today, the main component of blood, which is your erythrocytes or your red blood cells. They have no nucleus and are made up of hemoglobin, which has iron as the conjugate group. So if you don't get enough iron, you become anemic. And they carry oxygen and carbon dioxide, which is what we're going to be covering today. Erythrocytes approach the lungs. There's a low concentration of oxygen in the erythrocytes and there's a high concentration of oxygen in the lungs. And because of diffusion, oxygen tends to come out of the lungs and diffuse in to the capillary, whilst the carbon dioxide diffuses down the concentration gradient to the other side. It may be difficult for the first oxygen to bind to the red blood cell, but when that has binded, the affinity, so the capacity to hold oxygen, increases, meaning it just wants more oxygen, becomes a bit greedy. So after it gets its first one, the second one is a little bit easier to attach, and the third one is even easier, and so on and so forth. It just gets easier and easier because the affinity for oxygen in the hemoglobin is increasing. When the erythrocytes approach the cells, the oxygen concentration is higher in the blood than it is in the cells, so it diffuses out to the cells, and the carbon dioxide is higher in the cells than it is in the blood, so it diffuses out of the cells and into the blood. Okay, so you can probably remember from last time that the affinity for hemoglobin for oxygen is really high. So now you're wondering, how does the oxygen be released from the red blood cells if the affinity is so high? Well, this is something called the Bohr Effect. Now, when you have a high concentration of carbon dioxide, the affinity for oxygen in the erythrocytes actually decreases. So lots of carbon dioxide means suddenly the red blood cell doesn't want the oxygen as much anymore, allowing it to diffuse out. And this is the Bohr Effect. Carbon dioxide is transported in the blood in 3 ways. The first way carbon dioxide is transported is simply as carbon dioxide, but this is only about 5% of the carbon dioxide. Some of it just combines with the hemoglobin and forms carbaminohemoglobin. Yes. And the rest of it, or most of it, reacts with the water that's in your blood to form carbonic acid. This is catalyzed by an enzyme called carbonic anhydrase. Those of you studying chemistry will know that acids dissociate, and this acid dissociates into H plus and HCO3-. The H plus reacts with your hemoglobin, forming hemoglobinic acid, I believe, and the HCO3- moves out of your red blood cells and chlorine moves in, which is called the chloride shift. Finally, when all of this carbonic acid reaches your lungs, the carbonic anhydrase converts it back into CO2 and water, and it is released into the air. So yeah, that wraps up today's videos. Thank you for watching, and give it a thumbs up and share. I did lose a subscriber this month, which is kind of sad,